afternoon, everyone, and welcome to episode 3 of GSO Ocean Classroom Live, Exploring the Mysteries of the Deep, which is funded by the Devereux Ocean Foundation. So thank you to Devereux for your generous support. Hello to all of our audiences out there on Facebook, YouTube, Periscope, through Twitter, and of course, our podcast listeners. Remember, if you missed watching previous live episodes or you prefer to listen to these events while you're walking the dog, driving, you can now find Ocean Classroom podcasts on Spotify and then Apple Podcast as well. If you've subscribed already and are listening now, thank you. If you haven't, definitely go and check it out. More information about the Ocean Classroom podcast, as well as video archives of previous Ocean Classroom episodes and all the associated resources, can actually be found out on the Ocean Classroom Live webpage through the GSO website. So we can share that link with you all. My name is Holly Morin. I am a marine biologist and a science communicator with the Inner Space Center at the University of Rhode Island's Graduate School of Oceanography. Super excited to be your host again today. The goal of these Ocean Classroom programs remains unchanged. So we're going to be sharing a lot of really fantastic knowledge with you, connect with some great ocean science experts. But we also, as always, aim to keep things super conversational, and your input is really what makes these programs a success. So you can ask questions at any time during the broadcast. So you're just going to want to put them into the comment box that's there below the Facebook video feed, or in the chat box if you're watching through YouTube. And we'll try to get to as many questions today as possible. We always like to kick things off with a question for our audiences first. So where are you all watching from? I am in North Kingstown, Rhode Island today. What city and state are all of you tuning in from? So be sure to go ahead and type that into the comment box or the chat box feature there. While you're all responding to that, letting us know where you're tuning in from, one quick reminder to remember to follow URI GSO and the Inner Space Center on YouTube and Facebook, so you can stay up to date on all of these episodes and other programs and more. And if you're watching a replay, thank you so much for joining us today as well. And if you have a question, type it in there. We do look at things after in the replays, and we can actually get back in touch with you with your questions if you're typing in them in there after the fact. So if folks have entered in their locations, now the time to see where we're tuning in from. I don't know how to say that in California. Ukiapa? I could be wrong. Sorry if I butchered that. Bermuda. Oh, must be so much nicer than it is right now in Rhode Island. We're gonna get snow tomorrow. Annapolis. Priscilla, hello. Peter is joining us from Providence, so just a little bit north of me. Jane Miner from Jamestown. Always a pleasure. This is great. Thank you so much. Saunderstown, we appreciate it. Right nearby campus. Newport, Rhode Island, on the other side of the bridge. Thompson Middle School, happy to have a classroom joining us. This is fantastic. Great. Thank you so much, everybody. We're super happy again to have everybody joining us today. So during today's Ocean Classroom event, we're going to be diving into the topic of ocean exploration. This is something we actually know pretty well at the Inner Space Center. And people often wonder, what do we mean by inner space? And it's not that pretty well known, or I at least remember it, late 80s sci-fi comedy. It's a movie, but it actually refers to the deep sea environment that wraps the majority of our planet. Over 70% of the Earth is actually covered by the ocean. So when you think of it, we have outer space, planets, stars, the amazing Perseverance rover, right? We all are pretty familiar with that. But then we have inner space for the Earth, that largely unexplored underwater environment. So I'm going to actually throw it to all of you again and have you think about how much of this deep sea environment, that inner space, do you think has actually been explored? And it's lunchtime. We'll give our brains a break. We're going to do percentages. So go ahead and type in there what you think about how much percentage-wise of the ocean deep sea environment have we explored. And while you think about that and write your answers, it's really incredible when you think that the mid-water column of the ocean, not the surface, not the seafloor, but that middle environment, that's actually where 95% of all marine creatures are found. It's pretty incredible. And then you think about the changes in environmental conditions that happen as we move through the water column. As you travel down from the surface of the ocean, there's an increase in pressure. So that weight, the squeeze of the water that's above you. Light disappears after about 200 meters water depth. So it's virtually absent, very dark. Can't see what you're eating. There's no photosynthesis. So chemicals, chemosynthesis becomes really important to some animals and some environments. No light, it's very cold, right? After about 200 meters, you're looking at an average temperature of 4 degrees Celsius or 39 degrees Fahrenheit. I think that's actually what the temperature was when I walked my dog this morning. So, and animals are adapting though to these extremes and thriving, which is fantastic. You have all these really interesting, sometimes weird animals that live in the deep sea. Fishes, they don't have their air-filled swim bladders because that would be crushed by pressure. So instead, they have bodies mainly made of water. Some have really big eyes that are adapted to low light. Others don't have any eyeballs at all because there's no light. What needs you have to see? You can use other senses, chemicals, sound becomes important. Animals have slower metabolisms. Their meals are limited, so they digest them slower. They produce their own light. They're bioluminescent. Some don't have any color at all because, again, there's no light, so there's nothing to reflect. It's all incredibly interesting. And those extremes adaptations are for the technologies we use to explore the deep sea as well. And it's crazy to think, you know, Greeks, Egyptians, Vikings were always exploring the surface of the water. And then in the late 1800s, you have the HMS Challenger, which was a sailing ship that was transformed into a laboratory ship that was actually usually marked the HMS Challenger as the first oceanographic expedition. And they covered over 68,000 nautical miles, discovered more than 4,700 new species. Lots of samples were the first real major view of the seafloor is what they captured, including deep ocean basins. So you fast forward to today and how technology has advanced, and it's really absolutely fantastic to think about ocean exploration and what the different technologies allow us to do. And you can see that includes remotely operated vehicles or ROVs, autonomous underwater vehicles, AUVs, human operated vehicles, HOVs, and then autonomous surface vehicles or ASVs. And we'll get more into all of those different vehicle types and how we use them in just a little bit. But let's see, did anybody type in their answers? How much have we explored? 4%. Fantastic. 5%. Yeah, this is looking good. 20%, Mark. Thank you. What else? 0.5%. One more guess? No, excellent. Thanks so much, everybody. That was great. I always feel like Price is Right when I'm doing it. Somebody should shout out $1. But it really means, what do you mean by explore? Satellites have actually mapped all of the ocean seafloor, 100% of it, but at fairly low resolution, about 1.5 kilometers or 1 mile. And then less than 20% of the global ocean has been mapped in high detail using something called multi-beam bathymetry. And then if you think about what we've seen with our own eyeballs using remotely operated vehicles or other technologies, it's even less, around 10%. So those of you that were basically 20% and under, you were not far off at all. We have this vast resource that is largely unexplored, which is a great way to segue into our guests today. Some of these ocean explorers, scientists that are working to expand our knowledge and understanding of the deep sea. So Dr. Adam Soule is going to be joining us today. He's joining us from the slopes of the Adirondacks, and we really appreciate that. He's a relatively new faculty member here at URI GSO in the Marine Geology and Geophysics Department. He has expertise in hydrothermal vents, and his research focuses on volcanic processes. So he joined us in January this year. He has come on board not only as a faculty member, but also as the executive director of the Ocean Exploration Cooperative Institute. Also joining us today is Jason Fahey, who is an ocean engineer and a Naval Academy grad. He also joined us in January, and he is the associate director of the OECI as well. So Jason has significant experience working with a variety of ocean technologies. He's sailed on a variety of ships, including the EV Nautilus, which is one of the various vessels we connect with at the Interspace Center. Jason, why don't you go ahead and say hi to everybody and let them know a little bit more about your ocean exploration background.
Holly, thanks for doing this. This is super cool to be able to participate with so many people on so many different platforms. So thanks for setting this up. My background, I'm a 20-year career naval officer. So I left the Naval Service after 20 years and joined the University of Rhode Island to work with Adam at the Cooperative Institute. And so my experience is a little different, right? I don't have, like Adam's, a career in academic ocean exploration. I've been out on naval applications, right? So my work with autonomous systems has been in the context of defending our country or collecting information that will be valuable for the Department of Defense. And so it's a little bit unique in that regard, but the fundamentals are all the same. It's amazing how little we know about the ocean, even as a naval officer. You know, to imagine that if, I don't know what the winning vote was on the how much of the seabed has been explored or mapped, But no matter what it is, imagine being a submarine skipper, right? And knowing so little about the environment. And you see, like in a naval context, we see like the USS San Francisco that ran aground in a seamount, right? This was uncharted, right? There's portions that submarines are running into. No fault of the captain. I'm sure the Navy found some way to blame the captain, but it wasn't on the chart, you know, like we just didn't know it was there, which is crazy to think about. And, you know, you hear people like Dr. Mayer talk about how much more of other planets in the moon are known in much finer resolution than we know about our own ocean. And so I'm bringing my naval experience to the university at URI. I'm really focused on the autonomous vehicles in our portfolio at the Cooperative Institute and really building this network of these 5 partners together to multiply the value we can add to ocean exploration. So yeah, that's me, I guess. Yeah.
That's great, Jason. I think I really appreciate though how you said that the naval aspects of, you know, using vehicles and underwater technologies, even though it's for, you know, defending the country or has military applications, the fundamentals are the same, which I think is really important to point out. So let's bring Adam in. So Adam, he joins us not today, but he was before he joined GSO. He was with Woods Hole, and he's a chief scientist, there for the National Deep Submergence Facility at Woods Hole. And now, of course, he's the executive director of the Ocean Exploration Cooperative Institute, OECI, at URI GSO, as well as being a marine geology and geophysics faculty member. So again, Adam, thank you so much for joining us today. Why don't you go ahead and say hello to our audiences and let them know a little bit more about your research experience, which focuses on hydrothermal vents, and maybe speak a little bit more about the OECI and what that Cooperative Institute is.
Thanks, Holly. Yeah, so my background started with volcanoes on land, fell in love with these amazing geologic features, and then started to work on those same systems underwater using a variety of different platforms, many of the ones that you mentioned. When I finished my PhD, that's what I looked like. No, I'm just kidding. That's when I was a little kid out in Hawaii. But now I'm running this Cooperative Institute, and the goal of it is really to accelerate the technological developments and pace at which we can explore the oceans, especially within the US EEZ. As you mentioned, there's so much left to explore and characterize. And as you said, it really depends on kind of the scale you're looking at. If we think about the microbes that are in these environments, we've explored it, you know, almost none of it. So we are bringing a bunch of groups together to build tools and a system to explore the oceans more effectively and efficiently.
Excellent. Thank you. Thank you, Adam and Jason, for those great intros. And an invitation, a reminder to everybody out there, all of our audiences, that this is a conversation and we want you all to be part of that. Remember to type in your questions and comments there in the chat box or the comment box at any time, and we'll get to those as many as we can. So hopefully this little bit of information has gotten those juices flowing. If you're curious about our guests' academic experience or their backgrounds, different aspects of their research, maybe the coolest thing they've seen underwater, any of those questions are all fair game. Definitely put them in and ask. So when we're talking about exploration, I mentioned some of those tools, Adam and Jason, at the beginning, those different technologies that we're using. So how do these tools, or can you talk a little bit more about these different tools? Adam, I know you've had a lot of work with Alvin, the human-occupied vehicle that we showed, or that I mentioned. You know, what is that tool used for, and have you used it for your research with vents?
Yeah, so there's the variety of tools that you mentioned. They all have in common is that they're giving people access to the interior of the ocean. And Alvin is probably the most literal example of that, where you're bringing a human down to the seafloor to make observations and to collect samples. I've had about 25 dives in Alvin for my research, and I'm going to have a few more coming up in the fall when the sub is going to be able to dive to 6,500 meters depth. But remotely operated vehicles and autonomous vehicles are both doing the same thing. They're allowing us to make observations in an environment that otherwise humans wouldn't be able to survive in.
And how are they built? And I don't know if you both can speak to this. So there are obviously the extremes. How do they survive in these extreme environments? What type of process is there for testing them, or what type of tools do they also bring out with them to use to sample the environments? What do you think, Adam?
Yeah, so if you're building a robot, what you don't want to do is expose it to salt water, and yet that's the environment that we're working in. So it's a really difficult environment to operate in. In addition to the kind of corrosive environment or the salt water, there's also the pressure, and there's a variety of technologies that allow them to operate in this environment. And once we're down there, though, there's all sorts of ways that we're gathering information. Sometimes it's sensors that are just measuring the water around the vehicle, and sometimes it's hydraulically controlled manipulators that can grab something off the seafloor. And you'd think that is, great. You have a claw, you can grab stuff, but those claws are really strong, and so we have challenge sometimes when we're trying to grab really delicate things, and people have developed kind of soft robotic fingers to do that. But some of the tools that we use are as simple as what you'd use in your backyard, a shovel to scoop something up.
Yeah, and I think that the key thing to point out is that, especially with your ROVs, so Jess, that image you had of Deep Discoverer, that was great, where those are actually being controlled by somebody who's on board the ship. So there is a pilot on board the ship. The vehicles are tethered to the ship, so you can see here, and it gives you a really great sense of scale. These are about the size of a good-sized minivan. So they're not small for sure. You can see the manipulator arms there in the front that are closest to you. They're kind of bent up and over. But what you'll have is these are tethered. You can see the gentleman was actually holding lines, but there are tethers coming off the ROV, and the pilot sits, and I always say, if you're a gamer, it's a great way to, it's a great parallel, right? It's almost like you have your own game controller on the ship to control the manipulator arm. And they're able to actually, extend the arm, open and close it. They can feel with force feedback if they've picked up something heavy and or need to put more pressure, to pick something up. It's really fascinating, these pilots, what they're doing. And then there's also, though, Jason, a navigator, right, that's helping, because I know you've been out on the Nautilus on these different ROV cruises. And it's really, they have another ROV that's a camera sled, and there's a dance that's happening between the ROV that's doing the sampling, the camera sled that's, kind of maintaining imagery above the ROV, kind of giving you a bird's eye view, which is always nice. And then the ship. So you were a navigator. What does that involve?
So I think one thing that we should cover is the difference between, you showed the graphic of Alvin, right? And then you showed the Deep Discoverer, the remotely operated vehicle. The remotely operating vehicle is connected to the ship. And so the pilots are sitting in a container or in a laboratory on the ship and have a team of people supporting them, right? And I was a navigator. I did the planning for where we were going and the positioning of the ship and the ROV, and kind of directing the pilots to those locations in support of the scientific mission. But all the functions of this team that's on the ship supporting the remotely operated vehicle are done on board Alvin, right? So the humans that are in the sphere at depth on Alvin are figuring out all this other stuff, right? They're controlling the manipulators, they're maneuvering Alvin, and they're planning where they're going next and worrying about the health and status of all the systems on board. And so I have never been in Alvin, but I cannot get over the amount of responsibility and tasks that are packaged into piloting a almost full ocean depth manned submersible. And that's what Alvin is, compared to the relatively easy task of a remotely operated vehicle, which is supported by the ship, and you can have all this space and you can go get a cookie, it's just different, right? You're down there for hours and hours and hours. And, I don't know if this is appropriate for this channel, but you got to have a poo plan, like these bodily functions, these things that happen, there's got to be a plan for that. And it's so interesting. I had more of that kind of experience in my Navy diving life as a naval officer, than maybe I did as an ocean explorer, because I was a ship guy, right? On the ship as an explorer, we run robots. And so, they are packaged to do their own thing, and we are on the ship doing our thing, supporting them. But Adam's experience in Alvin, that is like it's awe-inspiring for me to think about. Well, especially, it's hard to tell, but I'm very tall, right? So I am very intimidated. I'm 6 feet 9 inches tall, and I'm very intimidated about cramming someone into that sphere on Alvin, especially somebody like me. I mean, I don't think I could get through a test fit like in the hangar.
Adam, what is it like as somebody who's been in Alvin?
Oh, it's fantastic. I mean, it kind of changes the way that you see the oceans. But Jason's right that there's only 3 people in the sub, a pilot and 2 observers. And when you're using a robotic vehicle and you have all this collective expertise on the ship that you can apply to whatever you're seeing. So you do feel a lot of responsibility for your colleagues, that want a biological sample or a geological sample. But seeing those environments firsthand is really incredible. Yeah.
Awesome. Adam, it looks like we actually have a question for you about underwater volcanoes. So let's bring that question up. Thank you, Mary, for your question. How do you determine how violently volcanoes erupt underwater and how that affects the health of the ocean? What a great question.
That is a fantastic question, Mary. So one thing is that up until a couple decades ago, people didn't think that violent eruptions occurred underwater because of all the hydrostatic pressure. It keeps the gases dissolved in the magma rather than making bubbles and exploding. But we found over the past few years, or 5 or 10 years, that there are explosive eruptions underwater. And they can have really significant effects on the environment around them and the water column above them. So you're looking here at some video from West Mata volcano. This is near Fiji and Tonga. And big gas bubbles are exploding and kind of bursting out of the seafloor. This is one of the few submarine eruptions that we've ever witnessed in person. And this was with the Jason ROV. So you can see the stuff floating upwards. That's going to make a plume that can go all the way to the surface of the ocean and fertilize the ocean with nutrients that biological organisms will use. And it's also going to cover the seafloor with ash, which is going to cause potentially local extinctions in and around the volcanic vents.
Fantastic. And then this is some imagery of I think this was lava that you said was covered in volcanic ash. It's really fascinating because it's orange.
Yeah, so these are lava flows up at the Gackle Ridge in the Arctic Ocean. And this is 4,000 meters deep, so it's quite deep. And the lava flows are orange because when they were hot, this orange colored bacteria that oxidizes iron grew on them. And then when it cooled off, they died there and left that orange stain, but it's covered with this dust. And this is kind of ash from volcanic eruptions, really deep on a mid-ocean ridge, but producing explosions that make this fine ash and spread it around the seafloor. We still have a lot to learn about these processes. We're just in the infancy of understanding them at all.
And that's the beauty of ocean exploration. It's that curiosity and then figuring these things out and never quite knowing what you're going to find. So we have a question that was submitted in advance. This is something that you all can do, is that we do have a form to fill out that if you want to send a question in advance, you can. You can even do video questions. But this question came from Ryder James Davis, who is from Rhode Island. Hi, Ryder. Thank you for your question. How far have you been down in the Mariana Trench, and have you tried to go deeper? So for those that don't know what the Mariana or Marianas Trench is, it's a crescent-shaped trench located in the Western Pacific Ocean. If I recall correctly, I'm not a marine biologist or marine geologist. I'm a marine mammal person by training, but it's the deepest trench on Earth, and it reaches upwards of 36,000 feet or 7 miles in depth, and it's the deepest part of the ocean. And I always like to think of, you have multiple people or thousands of people that have climbed to the top of Mount Everest, which is the tallest point on Earth, but only a few have actually reached the depths of the Marianas. So I don't know, Jason or Adam, I don't know if you're one of those chosen few that have gotten to go into the Marianas, but if you want to add thoughts about who's gone down into the Marianas and if there's thoughts of going deeper. I know, Adam, you actually have footage from the Chromatic Trench off of New Zealand, which is another pretty deep oceanographic feature as well.
Yeah, so the first folks to go down in the Mariana Trench were Jacques Piccard and Lieutenant Don Walsh. And it's kind of a cool story because Jacques Piccard is the son of Auguste Piccard, who was the fellow who invented the first research submarine called Trieste and its previous versions. And other than that, only 2 other people have been down there, and they have kind of some big names. James Cameron, the director of the Avatar films and Titanic, as well as Victor Vescovo. The Chinese have built a human-occupied sub that can go to the deepest parts of the Mariana Trench, but there are really very few vehicles, tools that can withstand that kind of pressure. I mentioned that submarine Alvin that can dive to 6,500 meters. That gets you about 2/3 of the way to the deepest part. And many of our vehicles are built to go to 4,000 or 6,000 meters. That's a ton of seafloor that's available to you at those depths. In fact, at 6,500 meters, you can reach 99% of the ocean floor. It's just that last little bit, small bits in these trenches that go down to 11,000 meters. But they're really important because animals have adapted to live in those environments, and that's a really unique part of our planet that should be explored.
Definitely, definitely. And then on that same idea, then I'm going to ask you both this question. You've both had different experiences and various experiences with technologies and exploration, different maybe applications. What is your favorite discovery? What is your favorite moment of discovery or favorite experience that you've had so far on this journey? Jason, why don't I throw it to you first?
Okay. For me, it might not be as specific as you're looking for, but the moment for me was I was on the exploration vessel Nautilus, and we were exploring with the ROV, and I had been asked to function as a watch leader, instead of being navigator, which is like a subordinate position. Finally I'd been out a couple of cruises, and the team asked me if I could cover a 4-hour shift as directing the exploration. And it was at that moment when, you're directing the orchestra that's piloting the vehicle, and you're really trying to achieve these scientific goals, that it dawned on me that we were the first to ever be there, the first to see and experience that piece of seafloor, that bit of ocean. And, it might sound dumb, but it was really cool. And that sold me. I was hooked, that it's just the original nature of the exploration, and that what we might see as routine in our business is so new every time we go and do what we do. That's my favorite experience. I've got, and there's photos that I'm sure Jess can pull up of me wearing my deep sea diving equipment and doing all, Navy related stuff. But the ocean exploration is really where is the focus of the rest of my working life. Really, I'm very excited especially to be able to share what we learn. The Navy, we learned a lot, but it was kept internally. And so that outward facing kind of portion of exploration is really cool to me too.
Awesome. I love that tagline, ocean exploration, it's routine, but always new. I think that's great. Adam, what about for you? A favorite discovery or discoverable moment or just an experience that you've had? Did we lose Adam?
Yeah. So can you hear me?
You're good. You're good.
Yeah. Okay. So we went to this volcano off of New Zealand called Havre, which had a big eruption in 2012. And we collected a map. We made a map of the seafloor, and I thought the mapping tool was not working well because the seafloor was really lumpy. But when we got down there, we found that it was covered with giant pumice. So if you've seen a piece of pumice, it's basically the size of your fist. But the size of the pumice that we found down there were as big as minivans. And I had never seen anything like it in my life. We actually recovered one of these by taking everything off the vehicle. You can see the video here, and kind of hugging it as we came up. And it was really important scientifically, but it was also just the first time anyone had ever seen these outside of like the historical rock record, like in a cliff, you know? So it was amazing to me, and illustrates kind of almost anywhere you go in the deep ocean, you're going to discover something that you know, is virtually unknown to science.
That's great. The imagery is fantastic. I'm just thinking though of an ROV with its arms wrapped around this giant geological sample, hugging it. I don't know, that image in my brain is quite funny, but equally exciting at the same time that was able to even happen, because you think about the ROV is of size and it's hugging this giant geological sample of pumice. What was it like when that came up on deck, Adam?
It was 1.5 meters, so it was like 5 feet long and 4 feet wide, or 3 feet wide. It was enormous. It couldn't be lifted, I guess is the.
Yeah, that's just crazy, but that's the
Did I
beauty.
lose you? Sorry.
No, you're fine. Not a problem at all. We appreciate, actually, we've hit our 30-minute mark. So thank you everyone for joining us today. Thank you, Adam. Thank you, Jason. Thank you to our audiences. We had a lot of really great questions, and hopefully you all have learned something new about ocean exploration, have a broader understanding of the deep sea environment that covers a big chunk of our planet, and the different tools and technologies that can be used to better understand it. We always like to round things out, because this is a classroom event with some homework. There are some really great activities on the NOAA Ocean, the NOAA OER, and your EV Nautilus about ROVs. And you can go ahead and build out a manipulator arm, or maybe your own robot. So check those out. There's also something called Sea Perch ROV as well. Stay tuned for upcoming exploration season details. So both the EV Nautilus and the Okeanos ship, the Okeanos Explorer, will have active exploration seasons in 2021. So all of those details are slowly coming out and getting posted online. So definitely check out their websites, or you can follow along on social media to find out those details as well. And then also make sure you stay tuned for more details about GSO's Ocean View art competition. So we've received a lot of different submissions. So now after that tremendous response and all the submissions are being curated, there'll be information about opportunities to go view these various art pieces, which of course have been inspired by the ocean. So thank you, Jason. You have been a great guest today. We really
fun. Hey, did you see Anne's question, or Anna Perez's comment about the Cascadia subduction zone? It sounds like good material for maybe another episode.
Well, that's a fantastic segue, Jason. So that comment, definitely put that into the form. There's going to be a link that's shared to future episodes. You can provide feedback, the audience can, to go ahead and help guide future episodes. If there are topics you'd like us to explore, definitely let us know, and put that information into the feedback form there. So thank you, Jason, for pointing that out. Thanks to everyone behind the scenes for making the episode work flawlessly as usual. Thank you to the Devereux Ocean Foundation for their continued support. And again, one last thank you to our audiences for taking time today, whether it's your lunchtime or another time. We really appreciate you joining us. So mark your calendars, future episodes. April 1st, no joke, it'll be at 4 p.m., not noon Eastern. So we're going to be starting a little bit later, so mark your calendars for 4 o'clock that afternoon. And then on April 15th, we'll be talking about underwater acoustics, and that'll be back again at 12 p.m. Eastern time, so noon. Don't forget to follow along URI, GSO, Interspace Center on social media. Podcast listeners, continue to subscribe, share. We really appreciate that. And then, stay tuned for more of these events. We always appreciate everybody joining. Until then, though, stay safe, be well, and thanks so much. Take it easy, Jason. Take it easy, Adam. Thanks, everybody. Bye.